So what's our next step? Well, let's go back to our step-by-step stuff and look at it. Okay. We made a skeleton entity manager. It had nothing. Selection manager. Ooh, we didn't make this globally accessible. We did this. Now we have to add this, and then we can look at the other things. So let's make final fixes to this. We've got entity 381, and then start writing the physics aspect. Okay. So what is the fix we need to make to this? Well, entity manager has this. We want the same kind of pattern in all our managers. So I'm going to say public static selection manager inst public, no, not public, void awake. And Unity knows about awake, and now C# knows about awake. So even if I just type awake, it completes the entire function for me. Inst equals this. So this is obviously the object of this class. If you're if you've done a lot of programming, you can see that I'm trying to create what's called a singleton, and I'm doing it in a very, very, very simple and not secure way. But it suffices for this particular class because we are not interested in how to make singletons and other design patterns. This class is about game engine architecture. Okay, so we did this. So now, what is the simplest physics we can do? All right, let's see. Assuming that someone has set desired speed and desired heading, what we have to do is make heading go towards desired heading and speed go towards desired speed. So the simplest thing to do is to deal with, I think, speed, because it's kind of simple. So let's do that by saying if speed is less than desired speed, what I want to do is speed equals speed plus acceleration star. Oh, but this is physics. This is not the entity class. No. This is what physics is supposed to do. This is not what the entity class is. This is just a holder for stuff. I don't want anything in update here. What I have to do is add a component. And the component that we're going to add is another script, and we're going to call it oriented physics. This will be our simple 2D oriented physics. It might become 3D later, but for now we'll call it oriented physics. And we'll put that code here. Okay. So, hey, wait a sec. How do I get entity data? Well, what I have to do is public. I need a pointer to entity data. So entity 381, and we'll call it entity here. Right? Then I can say entity, then I can say if entity dot speed is less than entity dot desired, not heading, speed, then do stuff, right? But I still haven't connected the two. Save it. and then just move this entity over here and it will put the correct part in there. Okay, do the same over here. Here I want to call it oriented physics, and move this in here, and we're done. Okay. All right. So both of them will be running the same code. So what are they saying? If entity speeds, then entity dot speed equals entity dot speed plus entity dot acceleration star time dot dt delta t. Okay, delta time. Okay. Otherwise, I'll do the opposite. Right? Simple, easy to do. And okay, so now what do I need to do? Now I need to test if this works, right? Okay, so let's see if this works. How would I test it? Okay, so if I play it, let's test it on DDG51. Let's put it over here. And I wanted to move forward, right? So, well, so I can do this, and then I'm going to handle like heading changes, and then I'm going to say the usual physics stuff, which is well, I have to calculate velocity. So entity dot velocity dot x equals what is it equal to? Let's see, what is it equal to? What is it equal to? Sine and cosine, right? So math, floating point math dot sine of, so this is in radians, so I have to convert it to radians. Well, the way to convert it to radians, well, let's first do entity dot heading star. I have to convert it to radians. So I've got entity headings in degrees. So heading is in degrees. That's the convention. To make sure that everybody understands that, I'm going to say heading degrees. Okay, so if anybody reads this code, they know that it's in degrees. Because I understand degrees far better than I understand radians as a human. So I'm going to keep it in something I understand and then go back here and convert it. And it turns out this has the conversion. By multiplying with that, you get the sine of, you get the angle, which is in degrees, converted to radians, times entity dot speed, entity dot velocity dot y is always 0, and entity dot velocity dot z equals almost the same thing, except it's cosine. So you can imagine that Unity's degree 0 starts where and where it ends, because if this works, when I press the up arrow, when I press the up arrow, or when I set desired speed to be greater than 0, as it ramps up speed, it should go straight ahead. And when I set desired speed less than 0, when I set desired speed to be less than speed, it starts slowing down. All right. Mostly I want to make sure it doesn't move backwards. Okay. So if I press play, and this is the DDG51, and I set desired speed to 10. Oh, you can see stuff happening. You can see that it's moving up to 10. Oh, it keeps going back. Oh, this is not good. It keeps going back and forth. That's floating point math because it's not exactly ever equal to 10. Okay. Plus, it's not moving. And that's because I haven't calculated. What I need to do is actually say entity.position equals entity.position plus entity.velocity start time dot delta time. And then entity, then I can say transform dot local position equals entity dot position. And then that'll set the scene node's position. This is simply checking, this is simply computing the entity's local variable position. This is setting the transform. So if you look at DDG, both these scripts share the same transform, the DDG's position. Okay? All right, so hopefully this time I'll see it move. All right. It's playing, and you can see it move. It's already at 10, and it's kind of jerking back and forth around 10. Oh well, it set its position to 0 at the very beginning. To fix that, because I want them to be apart, and I want this, one way to fix it is to say this is your initial position. This is what we did last time. The other thing to say is, hey, I'm going to initialize you to 0, but when I start, I'm going to say position entity.position equals transform.local position. It'll copy it over here and nothing will change. Right, let's see if that works. Play. Okay, it stayed at the same spot and you saw that change. Okay, so then I can say desired speed is 15 and it should go. And I can say this guy's desired speed is 10 and it should go. They're both moving, all right. If I set it to 0, they should slow down, and if I go over here and set it to 0, it should slow down and stop. Okay, I like this. Except this slight change I don't like. Okay, there's some jitter because of this. The way to get around that is it doesn't know when to stop because it's overshooting and undershooting. So what we're going to do is we're going to say let's define a function that returns true if two quantities are approximately equal. And by approximately equal, I mean within an epsilon value of 0.01 floating point. We'll say return two values, right? So it has to be float A, float B, math f dot absolute. Oh yes, A minus B. The difference has to be less than epsilon. Okay. If you like parentheses, we can just put the entire thing in. This basically says return whatever the value of this expression is. This expression is true when this is less than epsilon. This is less than epsilon when the difference between A and B is less than 0.0.01. So what we'll say is, we'll say this. If approximately equal entity dot speed and entity dot desired speed, and that would be a smart IDE. Do nothing else. Okay. I don't want you to do anything and then skip the rest of that stuff. Note that I don't have a clamp for max speed either. So if this works, then if I did it compile, yes, if I press play and this is GTG51 and I say your desired speed is 15, oh yeah, it stops. Oh, perfect. See, this thing is not changing anymore. It's within 0.01 and it stops dithering. All right. And we're done. Okay, it's pretty fast acceleration, I must say. I think your acceleration needs to be a little slower, but we'll worry about that a little bit later. All right, max speed. And we're not checking for max speed. What we want is a nice little function here that clamps the speed. So we'll say entity dot speed equals clamp. Oh wait, I've got all these little utilities, approximately equal. I've got a whole bunch of these. So what I should really do is create a utilities class that contains all these little things. Let's see how to do that. We'll call it utils. Right, and okay, there it is. Okay, we'll just make it a public static class. We don't want it inheriting from anyone. So none of this stuff is going to be there since it doesn't inherit from mono behavior. And a public static class can only contain static members. So we'll say public. We'll just copy approximately over from, where was it? Oriented physics, right? We'll just take you over. We will cut you from here. We will paste you in here. And it's going to give me grief unless I make everything static. Then because it's no longer here, this is going to give me grief. So I have to say utils dot. And because it's static, it's available to everyone. Cool. So then I can write a simple function called clamp that basically clamps a value between a min and max value. So we'll say public float clamp, float value, float min, and float max. And what does it do? Okay, I don't want to call it value, because that can be a keyword. If value less than min, val equals min. If val greater than max, val equals max, not val. Otherwise, don't do anything to it and return this. Okay. This works because simple variables are passed by value. All right. So then I can say, before I do stuff with heading, entity.speed equals utils.clamp entity.speed must always remain between entity.min speed and entity.max speed. Okay, now I should never be able to go over 15. I can, oh, it's still running. All right, stop. Play. So let's see if I set it to 20. It doesn't go above 15.4. Perfect. This guy is 8. I'll set it to 20 as well. And this guy won't go much faster either. Okay, you can see it in both views, how things are moving. Right. Okay, slows down, everything is cool. I could put -10 and nothing will happen. Right, okay. So this works, all right. So now the difficult part that has to do with 360 degrees. So what I'd like is to have something like, what would I like? Kind of the same thing when it comes to this, like if utils dot approximately equal entity dot heading and entity dot desired heading do nothing, else if, so what do I want to do? I'm going to say so what I really want is something over here that is going to give me a an indication of whether to turn left or right. So I want something that if it's greater than 0, we'll kind of turn right, and if it's less than 0, I turn the other way. All right, so what I have to do is to write something that, given two angles, tells me, gives me the difference between the two angles as a number between -180 and 180. So if it's negative, I turn left, and positive, I turn right. Something like that. Static float angle diff. Okay, so I'm going to say it's going to give me difference. So positive, negative numbers. So float A, float B, and I'm going to say float diff equals A minus B if diff is greater than 180. Let's see, if diff is greater than 180, I want to return diff minus, I want to subtract 360 so it stays below 180. If diff is less than negative 180, I want to return diff plus 360. Otherwise, I just want to return diff. Okay, so this will make it not go below 180. This will make sure it doesn't go above 180, and I'll get something like this. Right? So then what I want to say is, if utils dot angle difference, positive, negative, entity dot desired heading is greater than entity dot heading, then it's greater than 0, then it's greater than. Then I want to say entity dot heading, if it's greater than, I want to turn right, so plus equals entity dot turn rate star time dot delta time. Okay. Then I want basically the same thing, but if it's less than 0, I'm going to go select, and here I'm going to say less minus. All right. I might calculate the heading, but it's not going to change it. So what I need is I need to change the transform. So transform dot local Euler angles. That's what I want to do. So this gives me the rotation around each of the 3 angles, x, y, and z axes. So what I would do is I want to change the degree, the rotation around y. I want it to be nt dot heading. Problem is I can't do this because in Unity I can't directly, I can get the value of y, but I can't set it. However, I can set the value of this vector. And to do that, what I'm going to do is I'm going to create a public vector 3 Euler rotation, set it to vector 3.0, and here I'm going to say Euler rotation.y equals entity.heading, and then I can say that set the whole vector. This is permitted, so then it'll rotate the ship in the direction of the heading. Let's see if this works out. Did I save everything? Utils, I just created this, I saved it. All right. So then let's see. All right, start moving, turn right, 90, 90, 90, 90, not 90 minus. Okay, it's turning, nice. Now I want you to turn to 270. Okay, started turning to 270. Let's see if you stop. Oh, it's going negative. Nice, 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 nice. Should stop it. Oh no, approximately equal will never be true. I got issues. It is turning the right way. So if I say 100, it'll turn. Okay, let's go back to 270. Small. Okay, nice. It's doing the conversion, so it should. Okay, so then if I say 90, oh, that's a problem. Okay, 180. Okay, it's doing quite well. I say 90, if I say 260, okay, if I say 0, nicely done. Uh-oh, this is going below negative 180. This is not good. This is going to be a problem. I don't want these things to stay. And I don't know what negative 2 something is. Oh, jeez. Okay, I don't know what this is anymore. Yeah, I don't want to deal with this kind of stuff. So. Yeah. So I'm going to change my code a little bit. Oh, good. This is what I want. I want something that'll take angles between negative 180 and 80 and return to me something between 0 and 360. Okay, so if angle degrees greater than 360, angle degrees minus equals 360, subtract. Right, if less than 0, I'll say less than equal to 0, angle degrees (360). I mean, it might go, you can just, as long as it's below greater than 360, let's make it smaller, and wow, it's less than or equal to 0, let's make it bigger. The negative degrees will, negative will come up, anything greater than 360 will get down. So then things should be much better. All right. Well, I'm not doing the right, not using it. So just like clamp, I'm going to say entity dot heading equals utils dot degrees 360. So entity headings is always between 0 and 360 because desired heading is also that, and I want to see that. So we've got this. Oh, stop, recompile, ready to play. Oh, I don't like that because it recomputed it because of the way I wrote this. I'm going to say leave it at 0. If it's only less than 0, if it's 0, don't add 360. I like 360. Okay. Compile. Okay, now. Okay, so heading and desired heading are okay. So let's have you move. You'll never get up to 20, but why not? 90. 180. 280. Alright, that's moving nicely. Okay. I think this should work well. And the same stuff should work for this guy as well. Go high, turn to 180. It's a fast turner, so it's going to turn really quick. Nicely done. All right, seems to be working quite well. Okay, so they're all moving nicely. I can see them. Things are going well. All right, so and the angles are, I'm hoping everything is remaining correct. Okay, so now that I've tested it, now I have to map the arrow keys to all this stuff. Arrow keys, and I have tab selection. I have to create some